This is my Physics 2211 Lab 1 video. So for the introduction and purpose, the Physics 2211 Lab 1 shows us how the principles of Newton's second law, which states that an object in motion will stay in motion unless acted upon by an external force, take place in the real world. It also teaches us how to compare and contrast experimental and coded data via glow script and tracker. My lab consisted of a ball and a rail system rolled across a mostly horizontal plane with a push in the beginning to facilitate the initial velocity. So here's what that looks like. I found from tracker and glow script that the ball's average velocity was very close to 1 the whole way through for both graphs, indicative that there was a constant velocity with very minimal forces acting on the system. More on that later. So for the system and surroundings of the video, the system was the ball and the surrounding was the grip with the track. So if we hop into glow script, my ball's initial mass was 1 gram. And the position and velocity vectors here are from this line right here, from the experimental values that I got from tracker, which are included here. So I just copy and pasted this into Excel. I got the graph, got the slope, and the intercept of the position function, and I put them here into glow script. Now it is worth noting that the slope here of the position function is the average velocity of the experimental values, position values. So as we come down here, we can see the momentum principles, Newton's second law. Here are the two equations. The ball's final velocity equals the ball's initial velocity plus F net over the mass of the ball times delta t. And here is the ball's position function. It is represented in the momentum principle as the final position equals the initial position plus the ball's velocity times delta t. And so here are those equations written out. So yeah, let's run the program, see what it looks like. So you can see that the ball's path is slightly less than horizontal, and it runs very smooth across the path. If you look over here at my tracker video, start from the starting frame, the movement is very similar. So if we go and compare our experimental and coded positions, experimental and coded graphs, from which our values I got from here for the coded, and the tracker I got the experimental. We can see that the slopes and the lines are very similar. And here they are. Now, some possible sources of error for my lab include hitches in the meter stick, which could be rough, or account for a slightly uneven velocity throughout. So they have a slight force on the ball as it moves across the track. And the points plotted in tracker were slightly off from the axis set, which I will show right here. They could be slightly off. As you can see, there are some fluctuations. So yeah. Our lab questions. Now, what if the axes were changed or flipped? Well, if the orientation of the axes was changed, the initial position and the final position of the ball would have been changed, as well as the sign of the slope of the position graph, or the average velocity. So the average velocity would change signs, but the magnitude of the average velocity, which didn't finish, but the average magnitude of the average velocity here would stay the same. Now, is it possible for you to say how many pushes and pulls are added together to give 0 net force in the case that you observed? Now, I think it is possible by observing the system as we saw in the video. It is clear that the ball is acted upon by a gravitational force, F equals mg, but it is matched by the normal force of the track. So the normal force of the track pushes up on the ball, and the gravitational force acts down on the ball, but the ball doesn't move up or down in the system, therefore resulting in zero net force on the vertical axis. And the net force of the ball rolling on the track horizontally incurs minimal forces from the friction of the meter sticks and the air resistance acting against its path. But for the purposes of the lab, the net forces in the horizontal axis are zero or negligible.